Hey everybody. I'd like to do a few sample problems with you dealing with calculating with waves. We have these three equations that we worked on yesterday or the day before, trying to make sense of them and making sure that they were as comfortable as possible. So now it's time to put them to the test and see how they go. So what I'm going to do is I'm going to work through uh, two kind of sample problems here. Um, that have some information but don't necessarily have a question written down. Because to be perfectly honest, in the real world, we often have a scenario and we look at it and go, well, can we figure this out? And then the answer is yes or no based on what information we have. So I'm going to do that, and it'll be close to things that we've done in class before, as well as the real world situations. So the first one is based on the pictures that you see up here. So this is a side view of the makeshift guitar of sorts that I made back at the beginning of this unit when we were exploring um, vibrations and waves, where we put a cup on a desk, and maybe you can see it here in the middle. Put a cup on a desk and then hung a string over the top of that cup, and then down with a mass down here off of the side to pull tension. So again, there's a string that's tied to the desk that's going, over the edge, and then there's a mass. Oops, there's a mass hanging over that edge that's pulling tension on it. I've added a few new pieces of information, right? And so the first piece of information here is that the length of the string from the cup to the edge of the table here is 30 centimeters or 0.3 meters. And so that's the string that we're going to be plucking with our finger to kind of get some information off of it. The other one thing that I've added in is this piece of information over here that states that the mass per length of the string, so that's in kilograms per meter, right, is this 4 times 10 to the negative third. Often this number is given, in scientific notation. We could, alter that amount and say 4 times 10 to the third is the same as 0.004, right? Yeah, 0.004. So that's the same as this value here, but often because it's a very small number, it's given in scientific notation, but that's the same thing as we go. So let's see what we can figure out from this. I'm going to solve for two parts. The first one is that I'm going to solve for kind of what's the velocity of the wave on a string like this. And then secondly, I'm going to figure out what the frequency is of the kind of fundamental modes vibration. So that's the first harmonic, right? That fundamental. And we'll go ahead and figure out what the frequency of that is. So starting out with the speed of the wave, we've got enough information to figure that out. And so I'm going to go ahead, maybe I'll work in kind of this blue color because it's different than everything else here. So if I'm solving kind of for velocity, I have this equation up above right here that essentially says that the velocity is equal to the square root, right, of whatever the tension of that string is, divided by the mass per unit length. Well, we happen to have kind of all of this information, and so we can plug this stuff in to be able to get what the velocity of the wave on that string is itself. So I'm going to go ahead and carry that square root over and plug in the pieces that I already know. This tension is over here on the side. The tension, I have it written right there as force with a subscript T, so the force of tension here, which is 100 newtons. Right. So often in physics, we end up with kind of a different label, and it's good to be consistent, but often we end up with things that are slightly different than one another. So Ft here is the force of tension. T down below is the tension. It's the same thing as things go. And then underneath here, I'm going to divide this by my mass per unit length. And as I said before, I have it written in scientific notation here up at the top. But I can go ahead and write that down in extended notations and put it in the 0.004, right? Because I'm moving my decimal place 3 to the left. And this is, again, in kilograms kind of per meter. Now, I'm going to solve this on a calculator to be able to pull that up. So I'm going to do this on my handy dandy calculator, which means you won't necessarily see it on the screen there. But all I'm going to do is I'm going to take 100 and I'm going to divide it directly by 0.004. I'm going to hit equals. And what I get from that is 25,000. So I'm going to take this, and this is 25,000 here. And if I work the units out for them, I end up getting meters squared per seconds squared, because you can break down newtons and make those things happen, but it's there. And then if I want to solve this, I need to take the square root of that, which puts us finally in this category of about 158. Now, there's a lot of decimal points that follow, but really I only have 3 numbers to work with here. So 158. And then when I take the square root of my units here, it's in meters per second, which is good because I'm solving for velocity. So the speed that I'm getting, right, is 158 meters per second. That's how fast the wave travels across its place. And I just wanted to make sure I'm still recording. Yes, I am. Sorry, I don't want to start this video and then realize I have to do the whole thing over again. Sorry for the pause. That was kind of awkward. All right, so there's our velocity. Well, let's go ahead and also solve now for the frequency. In the camp of the frequency, I now have a velocity from it. And if I look over here, I've got another equation which can help me out, where the second equation says I can figure out what the frequency is if I know the velocity and the wavelength. Maybe I'll work in green this time. So if I rearrange this equation just a little bit, the second equation, this one that says velocity equals frequency times wavelength, I can rearrange this to solve for frequency. And that means that now my frequency here is equal to my velocity divided by my wavelength. Right? That sounds okay. And I know what my velocity is now because I just got it from above, but I do have to figure out what this wavelength is. And you might be tempted to say, well, the length of the string is 0.3 meters, right, up here at the top. And if the length of the string is 0.3 meters, then that must be the wavelength. But it's not. Remember that the fundamental, or the first harmonic, right, is really only half of a wavelength. And you can see that kind of right over here, is that I only have a half a wavelength. So the entire wavelength is going to be twice that amount. So if the length of my string is 0.3, then the entire length of the whole thing is actually going to be twice that, right? And I could see that if I want to by using this kind of third equation right over here, where I could solve for the wavelength if I want to. But really, I can just know that if I've got this length of string of 0.30, that the wavelength itself, right, the wavelength is going to be twice that for this fundamental. So my wavelength is 0.60 meters, right? Because I've doubled what the length of my string is to get the full wavelength. So I can plug in those pieces where I've got this 158 meters per second. And then below that, my wavelength for my kind of fundamental there is 0.60 meters, so 60 centimeters. And all I need to do now is just divide. And I can do that pretty easily on my calculator as well. So I'm going to grab my calculator, which you can't see, but all I'm doing is typing in 158 and then dividing that by 0.60. And what I walk away with is a frequency of 263.3 repeating, or I'm just going to leave it as 263. And my units are hertz, which the meters cancel out, and I'm just left with 1 over seconds. And so that's what I've got. So I've got and 63 hertz is the overall amount. So what does that sound like? Well, we'll check that out in just a moment in the next video. So there it is, the velocity and the frequency of the wave that's on that string that we hung over the desk there and plucked. All right, thanks for checking it out, and I'll see you in the next one. Peace.